Hello everybody, I'm here to do some tests with you guys for your visualisation and fabrication, and we're going to look at structure. Week 8, stiffness. Stiffness. So we've got 4 different types of beams that we're going to measure. This one here, that's made of nitin, kind of gum. It's thin, it's rigid. A plastic one, check it out, it's a bit stretchy. This one here, good old Tassie oak, it's pretty strong. And this one here, which is a hollow piece of aluminium square bar.
The nitin's beam weighs 84 grams. The plastic beam weighs 188 grams. The Tasmanian oak beam weighs 150 grams. The aluminium square bar weighs 183 grams.
Having had a look at the 4 beams, can you make a prediction about which one will be the stiffest and which one will bend the most when weights are put on them? So we're going to test the stiffness of these 4 pieces of material. We're going to use this thing here. It's called a dial indicator. This dial indicator measures how much this little piston gets depressed, and it's extremely accurate. I've got it upside down because what we want to do is push things into it. Just be aware that it's upside down. Makes no difference. See how it's got a red reading and a black reading along here? Disregard the black one. We're only looking at the red.
Because the black one is in inches and the red one is in millimetres.
We've got a really small little dial here and then one large one here. This small one is for full millimetres, so it's got red. See that? See how it goes? 1, 2, 3, 4, 5, 10, 15, 20. So that will go around measuring the millimetres. This big dial is 1/100th of a millimetre increments. So it starts at 0 down at the bottom, same here, 0, and it will go 10, 20, 30, 40, 50, 60, 70, 80. Can you see when I press this, how it goes around? The big one goes really fast and the small one goes really slow. Kind of like a minute and a second hand on a clock. What I'd like to do is make both this dial and this dial go on 0. What I'm going to do is move this, and this will move this arm up and down, which will move this guy up and down, so push this piston in and out. And what our aim is to have this piston just touching the bottom of that piece of wood without pushing that piston in. So I want this dial to be on 0 and I want this dial to be on 0. Just the red one, see that? 0, 0. Because it's in 1/100ths of a millimetre, it's very, very sensitive. So you might get a little bit of experimental error. If it's like 2 1/100ths of a millimetre off, don't worry about it. So, as per our setup, and here it is, you guys have got the worksheets. We're going to set this up with the supports on either side of the dial indicator. These are the supports, here and here. We want these to be as far apart as possible while still supporting the load. We want our dial indicator to be right in the middle, or thereabouts.
Each one of our 4 beams is 610 millimetres long. The 20 millimetre overhang on each end of each beam makes the effective span between supports 570 millimetres.
So here's our first bit of wood. We're going to use the nitins. What we'd like is for this guy to overhang 20 millimetres. And that's because if we put a lot of weight on this and this piece of wood bends a lot, we don't want it to slide off the edge. We're going to make it 20 mils on this side as well. There we go, 20 mils or thereabouts.
I'm adding a 500 gram weight to the beam to hold it in place. And with that weight on the beam, I'm going to calibrate the dial indicator to 0. Here's my first 500 gram weight going on the beam. There's your measurement. Read the dial, write it down. The small dial reads less than a millimetre and the large dial reads 73 hundredths of a millimetre. Therefore, the material has deflected 0.73 of a millimetre. If you don't have enough time to read the dial, pause the video. Now we're putting the second 500 gram weight on the beam. I told you what the first measurement was, but from now on you're going to have to read the measurements off the dial indicator on your screen. And now our third 500 gram weight. And there's your third measurement. Don't forget you've got to read both dials, the smaller millimetre dial and the larger hundredths of a millimetre dial. Here's your fourth 500 gram weight. There's your measurement. Write it down. That's the last one in the data set for nitons. We'll take our weights off, take off the nitons and put on the plastic beam. This is our second material, a plastic beam. Again, we're going to put a 500 gram weight on the beam to hold it in place and calibrate our dial indicator to 0. Okay, our first weight, 500 grams. There's your measurement. Wow, that moved a lot. Write that one down. Our second 500 gram weight. There you go, your second measurement. Here's our third 500 gram weight. That's the third measurement in this data set. Better write that one down. And our fourth 500 gram weight. There's your measurement. So that was the final 500 gram weight in that data set for plastic. Here's our third material, a Tasmanian oak beam, which we will place on our supports with a 20mm overhang on either side. We'll place a 500 gram weight on the beam to hold it in place and recalibrate the dial indicator to 0. Okay, our first 500 gram weight. There's your measurement. Write that one down. Our second 500 gram weight. There's your measurement. It's not moving much, is it? Our third 500 gram weight. And there's your measurement. Write that one down, that's the third in that data set. And our fourth and final 500 gram weight for Tasmanian oak. There's your measurement. Write that one down. So you've got 4 readings for the Tasmanian oak. Let's take off the weights and remove the Tassie oak beam and put on an aluminium square bar, which is our final test material. We're going to put our 500 gram weight on the beam to hold it in place and reset our dial indicator to 0. First 500 gram weight. There's your measurement. Write it down. Second 500 gram weight. There's the measurement. Third 500 gram weight. There's your measurement. Fourth 500 gram weight. There's your fourth and final 500 gram weight for your fourth and final test material. And now you have the full data set so you can plot your results in the chart in your worksheets. Well, that's it. So thanks for watching and good luck.